axis right here called?
X.
X. Did you do the thing, Trey?
What?
Did you do
Some of it.
anything? Okay, so X, which one is Y?
The yellow one.
Good job, Leo.
Let's go.
Okay, alright. We're talking about graphing planes today. Sounds hard, it's actually not that bad though. You guys remember what a plane was?
Flies in the sky.
Yes, no. Oh. You guys need to go ahead and draw this. This is number 1. Sorry.
Oh gosh. This sketch will not be very good.
Your last piece of paper.
I was equal to 10.
But that's a big.
12, wasn't
12.
it? You said, I wrote 10, you said 10.
Yeah.
Oh, 12. I knew that. The Olympics theme song in my head.
It's this summer.
Oh, is it this summer?
I thought it was. Summer of 2024?
Do you think you swam with a guy that'll be in the Olympics?
I know a guy that might go to the Olympic trials.
Yeah.
Yeah.
Are you talking about like while he's in high school or like
Yeah.
college?
Well, he's still in high school. But this is his last year, so this summer won't be.
Alright, well, what we're going to do is find the intercepts, where it intercepts the x-axis, the y-axis, the z-axis. And the way we do that, to find the x-intercept, so remember any point on the x-axis from yesterday is going to have a y and z coordinate of 0. So that means if you put a 0 in for these 2 points, whoops, and then solve for x, this will give us the x-intercept. If I put in a 0 for z and a 0 for y, these kind of just go away, right? So all I'm left with is 2x equals 12. So if 2x, I didn't draw my graph big enough. If 2x equals 12, what would x have to be?
6.
6. You guys follow that? So if you put zeros in there, you get 2x equals 12, and therefore x is 6. So 6, 0, 0 is going to be my x-intercept, which means my graph needs to go out to 6. I only went to 5. Beautiful. Okay, and then you just do the same thing with the y and the z. So if I put in 0 for x and z, and I have 3y equals 12, therefore y is 4. So I'm going to put a 4 on the y-axis. And then for the z, if I get 0, 0, then I just have 6z equals 12. So z is 2. Okay? And you connect the dots. And then lightly with your pencil, shade in the plane. It doesn't work as well in smart work because I can't do light.
That's some good shading.
It is.
It's a real good shade.
I miss art class.
see, how far are we gonna have to go? Looks like 5 is how far we're gonna have to go. Uh-oh,
Uh-oh. It's because there's a negative.
there's a negative. I don't think they're gonna do that, little devils. Okay, we'll fix it when we get there. Okay. Little devils. Okay, if I cover up the y's and z's, 5x equals 10, therefore x is dos. If I cover up the x and the z, I get negative 2y equals 10. So y is negative 5, which means we need a negative y-axis. So that would be this way. 1, 2, 3, 4, 5. Your picture is supposed to look like kind of like a corner of a room. I don't know if you can visualize it. So I guess this would be like the next room over. Okay, and then if I cover up the x's and the y's, I get 2z equals 10, so z is 5. Okay, 5 and 6. I'll go ahead and draw it right there.
Some good shading.
Don't compliment him.
Because of understanding it.
Okay, so for number 5, it just says z equals 2. So where does z equal 2 at?
And then you
Go which direction?
go up to
Okay, but not just right there on the axis. Z equals 2. It's like a horizontal plane, infinite. How are we going to draw it? Well, if there's kind of some this number 6 is kind of like this one. If you flip back a page on 453, it has some, at the very top, it has some pictures to kind of help. Like it actually has z equals 2 in that picture, and y equals 3. So anyway, we got to try to draw a horizontal plane. It looks like it's going through that. Here's kind of what you do. The plane should be covering right there. There. So you gotta make it look like it's covering up. It shouldn't cover right there.
I need to shoot it in.
Yeah, I guess. Sure. No. Didn't work. That's ugly shading right there. All right. Okay, number 7 in the picture, it says let E461 be a vertex of the rectangular box shown. So E's out in the corner there. Find a Cartesian equation of each plane. So we just drew, okay, on A it says plane DEFG. You guys see plane DEFG? So horizontal plane, kind of like the one we just drew, right? So it's cutting through the z-axis. Where is it cutting through the z-axis at? 1. How can we tell it's going through 1? Because the point E has a z-coordinate of 1. So 7a, the equation would just be z equals 1. It's almost the same as what we just drew on number 5. Okay, B says plane ABED, which is the plane closest to us. It's a vertical plane. So would that be like an x equals or a y equals plane? What do you guys think?
X.
It's an x equals because it's basically cutting through the x-axis. It's going to have all the same x coordinates. And what is the x coordinate? 4. Because the x coordinate of point E is 4. It's cutting through 4 on the x-axis. Okay. C, well, guess what's coming? The one we haven't done yet. Plane BCFE, the one on the right, cuts through the y-axis. So it will be y equals 6. Well, we've done x, y, and z, so what could be remaining? Plane OADG. Which one is OADG?
An X and a Z. Put together.
No. Okay. I don't know if I can draw this. See. Let's grab the picture. So, yeah, I'm not going to fix it. So, this plane would be like y equals 3 if it goes through right there. It would look, well, I could clean it up a little bit, but, or this might be y equals 2 or y equals 1. If it's cutting through right there, it's just y equals 0. So, all these horizontal planes are like z equals. All these planes going sideways are x equals, and cuts through the x-axis. And all these planes coming out at us, like straight this way, vertical I guess you could think of it, are y equals. So if it's over here, sitting on the x-axis, it's just, and kind of on the z-axis too, it's y equals 0. Because all the y coordinates on that plane are 0. Alright, these are super easy. Well, turns out A vector that's perpendicular to a plane in 3D, 3x plus 4y equals plus 60. Let me write this one down real quick. You guys know what it means for a line or a vector to be perpendicular to a plane? That means it would have to be like sitting straight up, kind of. There is a line on the plane. It's 90 degrees with the plane. Anyways, a vector would just be like 3, 4, 6 would be perpendicular to the plane. So you can kind of just steal those numbers. Not sure why that works. I've never gone and read any proof for it. But anyway, vector 3, 4, 6 is going to be perpendicular to this plane. Yeah, so it's easy peasy. Today might be a little bit easy. Okay, 11 only says x plus y equals 4 though, so what do you guys think?
Vector 1.
1?
1, negative 4.
Nope.
Because you have to move it up.
Anybody else have a guess? 1, 1,
0.
0. 0. There is no z. Number 13. This one just says z equals 1. So it would be
1, 0, 0. What's
0, 0, 1.
Sebastian got that nailed. Dang it, no.
double the glory. It was your moment to shine. And you fell on your face. Okay, 15, we have to write our own equation. It says vector is 2, 3, 5, so guess what? Vector that's perpendicular to our plane is 2, 3, 5, so it's how do we find this number? Well, it says there's a point on the plane at 317. So how does that help?
You can plug those numbers in.
Right. That means if x is 3, y is 1, and z is 7, it should work in this equation. In other words, it should tell us what should go right there. So 2 times 3 is 6, 3 times 1 is 3, 6 plus 3 is 9, 5 times 7 is 35, 35 plus 9. 44. Zero, 1. Seems familiar. We did it like a minute ago. What's the 0, 1 perpendicular vector going to make the equation look like?
Z equals.
Z equals. Because that's like a 1z. No x or y. It's kind of the opposite of number 13. And then the point that is on the plane is 1, 4, 5. So, what does z equal? Take the z coordinate, plug it in for z. 5 equals 5. Alright, we'll stop there.